Hey guys, in this video we will be discussing metallic bonding. We hope you enjoyed our last couple of videos on the other types of chemical bonding, and remember to stay sciencey. So to recap, metals lose electrons to form full outer shells, making positively charged ions or cations. Here we have a sodium ion, which is a sodium atom that's lost an electron, and a magnesium ion, which has lost 2 electrons. Now over here, we have the structure of a metal lattice. This is how the cations are arranged within the structure. You also have a sea of delocalized electrons which came from the ions, which are arranged something like that, more or less. They're delocalized, they don't belong to any of the cations. What the metallic bonds actually are the forces of attraction between the positively charged cations and the negatively charged electrons. These forces, like ionic forces, are very strong. Now, a property of metals is malleability. Malleability is basically the ability to change shape under stress. And this is a strip of zinc, a metal, a transition metal. Now, I'm changing its shape just with my hands. Now, this is because of their bonding and their arrangement. Now, if I apply a force here to this layer of cations, it will slide. It won't disconnect like in ionic bonding because all the charge is positive and the electrons are evenly distributed, so the distribution of charge doesn't really change. So if I apply force, it just slides, it doesn't break. And that is when metals are malleable. So another property of metals is that they always have high melting points. This is because the forces between the cations and the electrons are very strong, so you need a lot of energy to break them, allowing them to change state. Here we have zinc with a Bunsen burner on the max flame, and you can see it's not melting. It is not even getting soft. Zinc has a melting point of about 400 Celsius. So it's not going to melt from that distance. If I put it in the fire, I have no idea what it's going to do. This could backfire. We will find out in a second. Move the tube, I don't want to melt the tube. That would be bad. Yeah, so I take the zinc, which I'm not going to touch because last time I touched something hot, I burnt my hand. No, it does melt. Cool. So, it does melt, but it takes a very high temperature. Say, Bunsen's go up to about 900. Now, magnesium has a much higher melting point, about, I think it's 800 Celsius. So if I put it in there, again, like the zinc, it's going to do nothing. If I put it in here, it's going to melt first, then vaporize, and then catch fire because it's just a really nice flame. Don't look at it too much. And is vaporized. Now that's the vapor catching fire after it's melted and vaporized. So clearly it does have a very high melting point. And for magnesium oxide, fun reaction. Another property of metals is conduction, specifically conduction of electricity and heat. Now if I apply these two wires to this metal strip, this zinc strip, nothing happens. This is because this strip is coated with a layer of metal oxide, which does not conduct electricity. If I take a cleaned zinc strip, you can see the light bulb is lit up as we formed a circuit. Now, this is because, again, of their bonding, the delocalized electrons act as free-flowing charges, which is what you need for electrical conduction. Now these electrons and also the fact that the cations are closely packed together means that metals can also conduct heat very well. And that is our last property. We hope you enjoyed this video and remember to stay sciencey.